Hello, I would like to go through two questions on coordinate geometry, and this is taken from the 10-year series for normal academic students. However, students who are taking Express may also want to consider looking at these questions, as these are quite challenging problems. Now, let's read the question. It's taken from 2018, paper 1, question 6. Sketch the graph of y squared equals to 9x. Okay, so for part 1, how do we draw a y squared equals to 9x graph? So you may want to consider it being, okay, if y squared equals to 9x, that means to say y is actually equals to plus minus 3 root x, yes? And if you can remember a root x curve, okay, how does it look like? It probably looks something like this, right? Okay, so if we have a plus minus 3 root x, it will probably look like that. Above and below the x-axis. So y squared equals to 9x. That's for part 1. And this is a 2-mark question. Now let's move on to the next portion. The points A, which is 1, 3, and B lie on the curve. Y coordinate of B is minus 6. So the midpoint of AB is M. Find the area of triangle OAM, where O is the origin. Okay, so we have so much of information. What can we do is to probably just piece down all the information in the sketch graph. Okay, so the first piece of information is A coordinates 1, 3. So let me just put this down. Okay, so let's say this is A, okay? 1, 3. And for B, they tell you that the y coordinate is negative 6. Okay, so negative 6 looks like I have to draw the line a little longer. Okay, maybe somewhere here. We do not have the coordinates, the full coordinates of B, but it is not impossible to find that out. If the y coordinate is negative 6, so let's sub the value of y equals to negative 6 into y squared equals to 9x. Okay, so from here we can find the x coordinate of B. So negative 6 squared equals to 9x. 36 equals to 9x. So therefore, x is equals to 4. And from here, we can tell the coordinates of B would be 4, negative 6. Now, what else can we find? Okay, so we have made use of the curve, we have made use of the y coordinate of B, we have found the coordinates of B. The next thing that the question mentions to us is that the midpoint of AB is M. Let's find M. So if you can remember midpoint, to find the midpoint, there's actually a formula. So the formula to find the midpoint, coordinates of the midpoint between two pairs of coordinates would be x1 plus y1 out of 2. Sorry, x1 plus x2 out of 2 and y1 plus y2 out of 2. Okay, so from here we will end up with 2.5, comma negative 1.5. Okay, so that's the coordinates of M. Okay, let me put M into the This must be 4. So if it is 2.5 and minus 1.5, okay. So let's say perhaps it is here. Okay, so this is M. Okay, and then B here, of course. Okay, so question wants us to find OAM. OAM. Where is OAM exactly? So O is the origin, A, M. Okay. Now, we can find this using the shoelace method. Okay. So how do we find the area of OAM? Let's start from O. You list down the coordinates and we go in an anti-clockwise manner. So after I have put the coordinates for O down, the next one, it will be B. B is 4, minus 6. Oh, sorry, I got this wrong. It's not B. It's M. It's M. M is 2.5, negative 1.5. Okay, then going up is A, which is 1, 3, and back to O again. So shoelace method, how are we going to multiply it? Top down first, top left to bottom right. So 0 times minus 1.5 will get us 0. 2.5 times 3, that will give us 7.5. 1 multiplied by 0, that's 0. Okay, so the first part, you multiply diagonally across and you add up the terms. Okay, after that, you subtract the product of the terms in a diagonal way. So 0 times 2.5, that gives you 0. Minus 1.5 times 1, so it will be negative 1.5. And 3 multiplied by 0, which is 0. Okay. So from here, if you were to simplify, within the first bracket, we have 7.5. Within the second bracket, you have negative half. But if we subtract, it's 7.5 plus 1.5. Okay, and from here, we will end up with our answer, 4.5 units square. So that's our solution for the question. Now let's take a look at another question on coordinate geometry. It says that solutions to this question by accurate drawing will not be accepted. Coordinates of the points P and Q are given. So find the equation of the line parallel to PQ and passing through the point minus 3, 2, giving an answer in a form that is stated. So to find the equation of the line parallel to PQ means we have to find the gradient of PQ first. Yeah. So gradient of PQ would be 13 take away 5 out of 7 take away 3. Okay, 8 out of 4, which is 2. Okay, so now the equation of PQ is y equals to 2x plus c. Okay, so let's sub one point that lies on PQ, find our value of c. So passing through negative 3, 2. Okay, so we sub this into the equation of PQ. Okay, so from here, what do we end up with? C is equals to 8. Okay, so the equation of the line is y equals to 2x plus 8. That's part 1. Oh, okay. The question also wants us to put it in this form, ax plus by plus c equals to 0. So ax plus by, ax plus by plus C equals to 0. Okay, so this would be our answer. Now, next part, we want to find the equation of the perpendicular bisector of PQ. Okay, so let's see. Perpendicular bisector of PQ means that the gradient can be found through the formula M1 times M2 equals to -1. Okay, so of the perpendicular bisector, it is -½ Okay, so now the equation of the perpendicular bisector is y equals to -½ x plus c. Okay, so what do we sub in? Well, the question tells you that the point, okay, we want to find the equation of the perpendicular bisector. That means not just the gradient of PQ, of the perpendicular bisector of PQ, we also need to sub the midpoint of PQ in there. Okay, so let's find midpoint of PQ. Oh, apologies. So 3 plus 7 out of 2. 5 plus 13 out of 2. Okay, 5,9. So we should be able to find the equation of the perpendicular bisector already. We sub this in. Okay. So we sub 5,9 into y equals to -½ x plus c. Okay, so c is equals to 23 out of 2. So from here, equation of the perpendicular bisector is y equals to -½ x plus 23 out of 2. Okay, and if we were to rearrange it, it will look something like x plus 2y take away 23 equals to 0. Okay. The next part, point R. Okay, let me show the question. A point R is at a distance of root 15 from the midpoint of PQ and lies on the perpendicular bisector of PQ. Show that the area of triangle PQR may be written in the form k times √3, where k is an integer. Oh, okay. So what do we do? I think we can sketch out. Yeah. So we have an idea how it looks like. Now, what are the points that we know of? We know P and Q. Okay. We also know the equation of the line that's parallel and perpendicular. Okay, let's draw it out. Okay, so we have PQ. Okay, and PQR, where is R exactly? So R is probably somewhere here. So we have to consider the midpoint Oh, sorry. So R is probably somewhere here. Okay. All right. So if they give you if they ask you to find the area of the triangle, that means we have to consider half times base times height to find the area of the triangle. Yeah, so half. Yeah, right now the title first, area of triangle equals to half times base. Okay, what's the base? The base is actually PQ, and the height is the perpendicular height, which is root 15. Okay, R from the midpoint. So let's find PQ first. PQ we can find based on the coordinates of this. Okay, half times base times height. The height is root 15. And from here, we manipulate. Within the first square root, I have 16 plus 64. Okay, and the second square root, we have root 15. So let's tidy up. Okay, and from here, we will end up with something like half multiplied by 1,200. How do we simplify? 1,200 equals to 400 times 3. And 400 is a square number. Okay, so we can write it as half 400. So 400, if we were to square root it, we will end up with a 20. And root 3 remains as root 3. So if we work this out, we will get 10 root 3 units squared. Hopefully these two questions can give you quite a bit of clarity with regards to coordinate geometry.